Hello, my name is Anthony Atkinson.
And my name is Marco Riani.
We want in this video to present one aspect of a book, our new book on robust statistics with 3 co-authors. We find our work very exciting and we trust that you will too.
So the dataset that we are going to analyze is the Hawkins data. We now show the y-axis plot of this data.
I can't quite remember the history of this, but Doug Hawkins generated these data, I should think, just before the end of the 20th century, that is, just before the start of the use of a dynamic robust regression as something that would fox any of the existing static methods for robust regression.
So here there are 128 observations. We have 8 potential explanatory variables, while the relationship between y and x8 seems to be positive and probably significant. It is not clear what is the relationship between y and the first 7 explanatory variables. Moreover, from here, it is not clear at all whether there are outlying observations. Now, we start doing a for research where we have the monitoring of scaled residuals here in the plot on the left, and on the right we have the plot of minimum deletion residual. That is the minimum deletion residual of the units not belonging to the subset at a certain point. The idea is that if the minimum deletion residual is large, then a unit which is not in agreement with those that you already have inside the subset is about to enter.
So use of these minimum deletion residuals is equivalent to the likelihood ratio test for an outlier.
Here we can see that around values of 90 there is a huge peak. Then it means that some units that are completely different from what is already inside is about to join the subset. Then this peak is followed by a decrease in the value of the minimum deletion residual. Then it is worthwhile to notice that there is another peak in the value of minimum deletion residual, and then it goes down, and then a third peak. Now we are going to explain these 3 peaks by analyzing and brushing the monitoring of the residuals. Here you can find that very close to 0 there is a set of residuals, then is completely mixed with that of the other observations.
When all observations are fitted, or nearly all.
This plot has a color map in the sense that the greater is the magnitude of the residual, then dark blue shows up. We start by brushing the largest residuals, and then we want to see where these units lie in the y-axis plot or in the plot of minimum deletion residual. You can see that these units have generally the largest or the smallest values of y, and these units correspond to those which are included in the search in the final step. Now we go on, and then we do another brushing. We brushing this second group here, and now we see the position of the second group of brushed units.
So if you look very carefully, you will see that they are there as azure crosses.
They are shown in pale blue. So you see that the first brush corresponds to the last peak. The second brush corresponds to the unit entering just before those of the final peak. And now let us see the third brushing. Now we use a magenta color, which is much clearer, and then this is the third brushing. We have identified the units which enter the search for this subset size. If we go back to the plot of residuals monitoring, you can see that there is a set of units that has a residual very close to zero. These are the unbrushed units. And then the residual for these units as the observations from the other groups join the subset are completely mixed with the others.
Yes, introducing the outliers into the subset used for fitting changes, of course, the parameter estimates, and hence these residuals as your residuals grow.
Now, if we hide the units that have been brushed, you can see that you end up with a nice linear relation between the last explanatory variable and the response.
Before we move on, perhaps you might like to look carefully at the plot of y against x8. I think this shows clearly that these are synthetic data. There are these neat bands that have no variation about them in the response. Okay.
Now we stop brushing. We go to the automatic procedure for outlier detection. That is, we call our routine FSR. And after calling our routine FSR, we automatically end up with 42 units declared as outliers. These 42 units are exactly the units that had been brushed before. Now we change with plot is equal to 0, and then we just show the completely automatic way the units that have not been declared as outliers. So far we have done the analysis using the forward search. Now we want to see what is the picture of the residuals as the breakdown point passes from 0.5 up to 0.01 to almost a non-robust fit. We use two raw functions, the power divergence raw function and the 2k by weight raw function. Power diversion is usually the one which takes the smallest amount of seconds. This is the monitoring plot of residuals using the 2k by weight raw function. Now we have the monitoring plot of residual using the power divergence, which is here in the right panel. These two pictures are very similar. You can see here now the set of largest residuals, the first group that we brushed before, then the second group and the third group. And then in pale blue, the units that have not been declared as outliers before. Now we want to have a zoom, a central part, in order to understand what happens. And then we do a zoom using both raw function, both the 2k by weight and the power divergence. What appear to be as a straight line, on the other end there are a lot of units, a lot of residuals, and they correspond to the group of units that have not been declared as outliers, and their residual decreases up to when the observations from the second group starts to enter the subset. You see that their residuals decrease and then they start increasing, and then the residual is completely mixed with those of the other observations. Notice that their residuals here increases in absolute value a lot when the other groups start joining the subset. We have used two different raw functions, the took it by weight and the power divergence. But from the practical point of view, there is just a slight difference in terms of residual, but the trajectories and the order has not changed.
Yeah, and any inferences about the fitted model or parameters or so on will be virtually unchanged.
So we can move to the conclusions for this analysis.
Doug Hawkins was really quite surprised when we sent him a forward search analysis of his data, which completely laid out, as we have seen here, the structure of what he thought was difficult to analyze. So the forward search is able to exhibit the structure of the data through a forward plot of residuals, the consequences of which on the plot of minimum deletion residuals are illustrated as a result of brushing. The two monitoring plots of residuals from S estimation show a similar pattern of strips of residuals as increasing distance from the central band of small residuals. In all three cases, the change to initial inclusion of outliers happens from a BDP slightly greater than 0.3. I should just like to add that this is an infrequent occurrence in that often the robust methods are based on, for example, S estimation, tend to downweight more observations than the forward search, and so to produce less efficient parameter estimates. Thank you.
Thank you. Thank you for watching.